x squared y. But now I'm in the inner function. But it's a product. I differentiate the first one. I get 2x plus. I copy the first one, but now I have to differentiate the second one, which is dy over dx. Do we all understand this step? Any doubts?
I don't think I get that step.
So this is the outer,
Mm-hmm.
and this is the inner.
Right.
I have to differentiate the outer, and I get negative sign of this.
Right.
And now I have to differentiate the inner. Exactly how we did it here. I differentiated the outer times differentiate the inner.
Mm-hmm.
I differentiated the outer, and now I differentiate the inner. Since this is a product, I differentiate the first function, I copy the second one, plus I copy the first, differentiate the second.
Okay.
It's the product rule. Is that okay?
So far.
Okay, everyone else, Tom, Landon, is this okay so far?
Yep.
Let me know if you have questions. Now on this side, I have 6x squared plus, I bring down 4, I subtract 1 from the power, it's a different rule, it's the power rule now, times the inner function prime. You always have to say times the inner function prime. Is this side okay? Is this side okay? Anyone?
Professor, when you differentiate
Yes?
2x cubed on the right, you get 6x squared. That's correct. And then 4y cubed. Which would be the inner function that you're differentiating?
Why?
Okay. All right.
That's why it's dy over dx. I could write y prime. It's not recommended.
No, not there.
Only because I may omit this by mistake, but I cannot omit this. So it's acceptable. If you don't like this notation, you can put y prime. It's acceptable, but you may miss something, or you may disconsider this and consider it y, who knows. But that's why this is like a, you know, like an eye scratcher. You can't miss it. But this one is easy to miss. So that's why we prefer this notation in place of differentiation. So now I have to distribute this function to these two terms, because I have to remove this from here and put them on one side. But I can't do it. I can't break this chain or product because it's a product here. So I have to first distribute to both terms. So I have negative 2xy times sine x squared y plus this times this. I shouldn't put plus because it's minus x squared sine x squared y times dy over dx equals the 6x squared plus 4y cubed dy over dx. So now let's see if this step is okay. Is this step okay? So yes. I distributed this here, and I distributed this here, and I have that. And then I have 6x squared and then this. Now I notice that the variable that I'm interested in is in two terms, but one of them is on one side, the other one is on the left, one is on the right. So I will move this to the other side, to the right, and I will move this to the left. So negative 2xy sine x squared y minus 6x squared equals, this was negative, so it would become positive, and then plus 4y cubed. And because these two terms have a common factor of dy over dx, I will pull it out. So this term is here. This term was brought from right to left. This term was brought from left to right. That's why it's positive now. Plus 4y cubed, because these are the two terms that have dy over dx in them. So then finally, in order to find dy over dx, all I have to do is divide. So on my page 6, so I have dy over dx is all this over all this. So x squared sine x squared y plus 4y cubed, and the numerator negative 2xy sine x squared y minus 6x squared. And that's it. Any questions? Any questions here? Any questions? Is this okay?
I don't have any questions.
Okay. Anyone else?
Okay, this one is okay so far.
Okay, that's it.
We could do, if we could do another, that would be great.
Say that again, Evelyn?
No, I was saying if we could find another example, that would be good.
Sure. Would you like to pick one, or this is under implicit differentiation? Is it something from Weber-Sine that you would like to pick?
I'm checking.
Sure. So this is implicit differentiation, and that was section 3.5. 3.5. Okay. I would like to look at a problem. Give us a function, please. Find the points where the equation where the tangent line, not the equation, tangent line is horizontal. Find the points on the graph of this function that you're going to give me where the tangent line is horizontal. Can anyone give us a function? Can anyone give us a function, please? Any function. Any function? Anyone? Okay, what about x e to negative x squared? I just made it up. I don't know if we will find points where the line is too horizontal, but it doesn't matter. So what do I have to find? What do I have to find in order to determine points on the graph where the tangent line is horizontal? What should I find
You need
first?
the derivative.
Yes, so let's find the derivative. What rule applies here? I know we know a lot of rules, but we have to identify which one so we can apply this correctly.
First, it's product rule. and
It
then
is,
it's
yes.
chain rule.
Thank you so much. It is the product rule. First function prime is 1, e to negative x squared plus the first function times. Can anyone help with differentiating e to negative x squared?
The e to the power of negative x times
Squared
2x
times
times negative 2x.
exactly. Perfect. Awesome. So I will factor out e to negative x squared, and I have 1 minus 2x squared. Awesome. So now let's focus on the tangent line being horizontal. What does that mean? When a tangent line is horizontal, what is its slope?
1.
0. So
0.
horizontal lines have slope 0. So all I have to do is just set this function equal to 0 because this gives the slope of the tangent line at any point where the function is differentiable. Set it equal to 0. Okay, so e to negative x squared times 1 minus 2x squared equals 0. Can this be 0? Can this be 0? Let's start with the easy one. Can this be 0? Yes. 1 minus 2x squared equals 0. Or 1 equals 2x squared. I divide by 2, and I have x squared equals 1/2. And then I have to take the square root. Remember, I need to obtain two solutions. It's x squared. So I get x equals plus or minus the square root of 1/2. So this is done. Now the question is, can this be 0? What do you think?
No.
No, never. Never. Why? Anything e to anything either looks like this, and it's never 0, or it looks like this, and it's never 0. So this will never be 0. Okay, so we found 2 points, not points, 2 x values where the tangent is horizontal. But the problem is asking us to find points. Okay, fine. So this is the square root of 1/2. This is negative the square root of 1/2. And now I have to find the y value. How do I find the y value? I'm going to write the function here so I can move that page away. When I have x values, how do I find the y value?
You can plug in.
Exactly. So I will have to determine f of the square root of 1/2 and f of negative the square root of 1/2. I'm going to plug this in the graphing calculator, of course. And where is this? What am I doing here? Where's my calculator? Here it is. So in y equals, clear, and I have x, and I have e to negative, no. I have x, I have e to negative x squared, and close the parenthesis. And I want second and table, and I want the square root of 0.5, and I want negative the square root of 0.5, and I should get the same thing. I should get the opposite, sorry. Okay, I didn't mean that. I wanted the square negative and the square root. Where's my square root? Okay, here it is, 0.5. They should be opposites of each other. So whatever this is positive, I should get negative because the function is odd. So positive 4.3, negative 0.43. 0.43, negative 0.43. So this is approximately 0.43. This is approximately negative 0.43. So the problem was asking us to find the points where the tangent line is horizontal for this function. And we did. What if it's asking now to find the equation of the line of any of these? No problem. So I have y minus y1 equals the slope, which is 0. X minus x1. So I have y equals 0.43. Good. So let's go back. For those of you who kind of just joined us, we are going through these topics. We looked at the problem with related rates, and we looked at derivatives and implicit differentiation. We can move on to anything else. Now, let me ask you this. If you have any questions. Do you need help with anything? Aaron and Talia, any questions? Do you need help with the WebAssign or help with anything else? Anything? Any questions? Yes.
Is it possible to go over a couple, just 2 examples?
Any
using
problem from any section? Yes, yes, yes.
Okay.
You
Let me
choose.
find a specific